But if you did, you'd probably go back and watch these just for fun, right? Okay. All right, so continuity at a point is what we're talking about today. All right, so quiet. All right, this is a very important section because continuity is something we have to prove for a lot of other theorems that we're going to use in this class. So in a lot of cases, quiet please, like if you want to apply L'Hopital's theorem, then you have to have a continuous function. I need to put him at the back of the road, don't I?
Let's switch seats, me and Noah.
We'll see. Okay. All right.
No, please, God, no.
Okay. All right. You might have to have some seats. I talk way too much. Okay. All right. So, a function f is continuous at x equals c. C is just a number here. It could be 0, 10, 5, 4, negative 3. Provided that f of c exists, the limit as x of c of f of x exists, and the limit as x approaches c of f of x equals f of c. So, if we are trying to prove in calculus that a function is continuous at a specific point, there are three things that we have to show. We have to show, first of all, that f of c equals some number. We'll call it capital L. Alright? So we have to show that if you plug in c, you get L. So think of that with numbers. If you plug in 2, you get 7. Right? So this is where the function is defined. This is your closed circle, where your closed circle is at. Okay? We also must prove that the limit as x approaches c of f of x exists. To prove that a limit exists, we have to show that the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x. So the limit from the left and the right have to be equal to each other, and we're going to say that they also equal some number L. And then finally, we've got to show that this limit as x approaches c of f of x equals f of c, both of which, of course, equal L. Yes? You still need to state the third. These problems show up on free response questions, not as much on multiple choice. So, and I believe tonight you should have a free response question or two on your assignment. You will take a picture of it with your phone and upload it to the AP Classroom. Hopefully that'll work out for you and won't be too difficult. Last year's class didn't have any trouble with it, so I'll show you. All right, let's do a problem. I think sometimes doing a problem helps. Okay. All right, so let's stop. One thing we're going to do really quickly is one-sided limits. Okay? So for one-sided limits, the first thing you want to try for one-sided limit, like we have here, the limit as x approaches negative 3 from the right, is just solve it like a regular limit from both sides. So in this particular case, if I plug in negative 3, I believe I'm going to get 0 over 0. I know it is in the bottom. I'm pretty sure it is in the top as well. I have 9 minus 15. Yeah, we get 0 over 0. So we could do the limit as x approaches -3 from the right, and we could factor the top, x plus 3, x plus 2, over x plus 3. X plus 3's cancel. What do we do after they cancel? We just plug in. You do have a removable discontinuity there. Good. For our limit, we're just going to plug in -3. So -3 plus 2 equals -1. That is your limit. So if you just work it out like normal, we have done that for limits that approach from both sides, right? Normally you wouldn't see that plus sign behind this -3. But the first thing you want to try to do is just work out the problem like normal. If you work out the problem like normal, that tells you the limit exists, so it means it has to be the same from both sides. So you can work, if it's something like this, you just work it like you have for all the other problems. Where we start to see ones where you can't do that is whenever you get ones like number 2 where you got a piecewise function. Okay? So we're going to look at the graph on this one, although you don't have to graph all these, but I like for you guys to picture what we're looking at. So let's see here. X is less than or equal to -2. And then I'm just typing this in as 2 separate functions, although it's one. Okay, so
What is that?
So
Oh, of course.
I have graphed this. These are 2 we don't know how to graph by hand, right? We don't know how to graph the square root of x squared plus 2, or maybe 3 over x plus 1 we might could graph, but we don't really want to, right? So what happens with this, I'm going to put this in here. Oh, it's not part of the graph. Oh, -2. So right here at -2, you've got that jump in the graph. That's where your 2 pieces of the piecewise function come together. So the question has asked us to find the limit as x approaches -2 from the right. Which function is on the right? The green one or the purple?
Purple.
Purple, right? That purple graph is the 3 over x plus 1. Okay, let me, so right here, that purple graph is the one on the left. So if I'm thinking about this graphically, right here, wherever that hits that line, it's hard to tell. Well,
There's a jump on.
yeah, so right here, at the end of that, it's actually an open circle, right? It's undefined right there. But that limit is going to approach that value because it doesn't matter for limits whether it's an open or a closed circle, right? So limits, it does not matter. So the function on the right is that second function. So if we're approaching from the right, the limit as x approaches 2 from the right of f of x is going to be this 3, I'm sorry, that should be a -2 from the right. 3 over -2 plus 1, which is 3 over -1, which is -3. So you can see here the closed circle is actually the one up here, right? That's where your closed circle is at because you got your or equal to here. But for limits, it does not matter whether it's open or closed. If it's from the right, you want to use the function that would be on the right side, which typically is going to be that bottom function here.
So you don't ever really know, it's just you're going to assume it's the bottom?
Well, like right here, I know because this is x is greater than -2, it's going, that tells me it's going to be the right side. almost always piecewise functions are going to be written like this. There could be some like cool problem out there where they flip these and your x is greater than -2 is actually on the top. So that would actually be the right, but I will not do that to you purposefully. And I don't think AP will either, usually, those questions. They're unusually cruel, but they don't usually do this. Like, they don't usually switch the piecewise functions. So hopefully they won't ever for us. So, like, if we want to think about this next one without graphing, we're asked to find the limit as x approaches 3 of f of x. Now, this is actually from both sides. But for that limit from both sides to exist, the limit from the left and the limit from the right have to equal each other. So, whenever we're asked to find this limit, we need to show where we find the limit as x approaches 3 from the left of f of x. You need to write this limit notation. We're practicing for free response questions. And if you don't put that limit notation and you just start writing down numbers, you won't get credit for the problem. So you've got to put this limit notation, limit as x approaches 3 from the left of f of x, and then you can show where you plug 3 in to that top equation because it's the one that's going to be on the left. So that's going to give you 6 plus 5, which is 11. So your limit from the left is 11. You also need to do your limit as x approaches 3 from the right of f of x, which is going to use that bottom function this time. That's the one that will be on the right side. So that's going to be 14 minus 3, which also gives you 11. So, have you guys seen this fancy symbol here before? Okay. This means therefore, and it is an accepted mathematical symbol. So mathematicians are notorious for trying to use as few words as possible. They prefer symbols over words lots of times. So if any of you out there are wanting to not write words, as few words as you can, then you can use this symbol if you want. You also are perfectly welcome to write the words out. But I think it's kind of pretty. Thomas likes words. So therefore, we can say the limit as x approaches 3, and I'm not going to put a plus or minus, so that means it's from both sides of f of x equals 11.
See, this I can understand, but I just looked at number 1 on the homework and I'm lost. Like, this is what happens every time.
Well, quit skipping ahead. I hadn't taught you everything yet, Daniel. I said quit skipping ahead. I hadn't taught you everything yet.
No, but like, the same thing happens with time. You always teach us something.
And that's our answer.
Yeah, and this is your conclusion. So
therefore, the limit is, okay, so
right.
what's that?
Right, and you could probably do this all in your head. You could plug in 3 and do that in your head and get 11. You could plug in 3 in the bottom one, get 11, and say, oh yeah, those are equal, so the answer is 11. If it's a multiple choice question, you're welcome to do that. But on the homework, I want you to be writing it out like this, if we have one like this, because these are a lot of times given on free response questions. And if you don't have the limit notation showing what this means, then you don't get credit because you're not justifying your answer. So, if this was a free response question, you would need to write all of this out for it to be correct. You could skip this probably, and this. They would probably be all right if you skip that because arithmetic they do not. They don't really count whether or not you're writing that out. So you could skip these pieces, but you have to have that limit notation. Right. You couldn't just put like equals 11. Right. You just can't say it's 11. You have to show that you've done the limit from the left and the right. If it's a piecewise function like this, if it's just a regular function, like if that first one, this first one right here didn't have that plus sign, you can just work those out like normal. But piecewise functions where you're limit from the left and right are different equations that you're using. You have to write it out. Okay. All right, so these types of problems we're going to see, we have to prove that the following function is continuous at x equals 2. So we've got this piecewise function. 2 is our cutoff point between our two graphs, right? So that's where our two graphs are going to come together, and we want to see if it makes one continuous line or if we have a hole in the graph or a jump or something of that nature. So there are three things you have to show. You have to show, first of all, you have to find f of 2. Okay, so to find f of 2, we're plugging 2 in. Which equation do we plug it into, the top or the bottom? Top. Okay, for f of 2, this is where you have the closed circle. The closed circle is going to be wherever you have the or equal to, right here. So we're going to have 3 times 2 minus 4, which is going to give us 2.
Wait, so why did you choose, I know the closed circle, but why?
Whenever we're finding f of 2, we're finding the value of that function. So it's not the limit, it's the value. So we have to use wherever we have that closed circle. Yeah. All right, now we need to know the limit as x approaches 2. But because we've got a piecewise function here, we got to look at the left side and the right side separately, right? So we're going to do the limit as x approaches 2 from the left. And make sure right here, you have to be doing the limit of something, so you have to put that f of x there. A lot of times I see students just write limit x approaches 2 from the left, and they don't put the f of x. That's technically wrong if you don't have that function there. So that f of x needs to be there. And then so if we plug in 2, we just have 3 times 2 minus 4. We've already done that, right? We got 2. So in this case, f of 2 and the limit from the left are the exact same thing, but you have to show them separately. And then we'll do the limit as x approaches 2 from the right of f of x equals 2 times 2 squared minus 6, which is going to give us 2 times 4 minus 6, so 8 minus 6, which also gives us 2. So that tells us, therefore, the limit as x approaches 2 of f of x from both sides has to equal 2. So the first thing we had here was we did f of 2. The second thing is we did that limit as x approaches 2 from both sides, and we had to consider those separately. The last thing we've got to do is just say, since f of 2 equals the limit as x approaches 2 of f of x, f of x is continuous at x equals 2. So that is the third piece. Yeah, you gotta have all 3 of those pieces. Yes. So you need all 3 of those pieces for the answer to be correct. Now, some of the questions you're going to get are going to be multiple choice, and you are going to have to make, you're going to have to read them and make conclusions based on what they've given you. But there are going to be a few that are free response, and those you'll need to write out, like this.
Is it on the textbook or AP?
It's AP Classroom. All right, let's look at another one. All right, so we have another piecewise function here. And we need to find out, for example, 5, whether or not this function is continuous at -3. And 6 asks us about 5. So this has 3 pieces that are put together. At -3, we're looking at the first 2 functions. So I need to find f of -3. So Ethan, which function should I plug into to find that?
-3, the very top.
The top one, which is just 2, right? Nothing to compute there, just 2. So I chose that because I've got the or equal to sign with the -3. Then I need to do the limit as x approaches -3 from the left of f of x. And from the left, I'm using that top function, which is just 2. I'm going to do the limit. I sure didn't give myself enough room here. As x approaches -3 from the right of f of x. And from the right, I'm using that middle function. 2 times -3 plus 4. Which is going to give me -6 plus 4, which is -2. Now, what can I say since those two don't equal each other? We're going to say, therefore, the limit as x approaches -3 of f of x does not exist. Therefore, f is not continuous at x equals -3. You must prove. Mathematicians also must prove their math. I think so. Nope, we can't move it. Unfortunately, the entire school schedule cannot be built around. Yes. All right. So if we're checking this for, or any questions on 5, if any piece of this is not true, if the limit does not exist, if f of -3 is undefined, or if you get answers for both f and the limit, but they don't equal each other, then it's not going to be continuous. So we would need to check 2x plus 4 and this function for 5. So to find f of 5, which one should I use, the middle or the bottom? Middle, because I've got the or equal to with that 5 there, so it's 2 times 5 plus 4, which is going to give me 14. I've got to check the limit from the left and the right at 5, so I'll do the limit as x approaches 5 from the left of f of x. That's what I just did. That was plugging 5 in there. It gave me 14. If you don't show it all the work for that, that's fine. I got to do the limit as x approaches 5 from the right of f of x to square root of 3x. Let me plug in for that x there. 3 times 5 plus 10 plus 4. That is 2 times square root of 25 plus 4, so 2 times 5 plus 4, which is 14, which tells me the limit as x approaches 5 of f of x is 14, because your limit from the left and the right are the same. And so we would say since f of 5 equals the limit as x approaches 5 of f of x. F of x is continuous at x equals 5. So this piecewise function is continuous at 5, but it has a jump in the graph at negative 3. Alright, we definitely don't have time to do all these, so let me see what. Yeah, we need to do this. Okay. So, this question says, what value of b will make f of x continuous at x equals 3? So, this particular piecewise function, you have this rational equation right here. It is defined everywhere except for at x equals 3. Right. So it's everywhere except for x equals 3, and it is not defined at x equals 3 because it's giving you a 0 in the denominator. Right. So what I need to know here, basically I've got a hole in the graph. B right here is just going to be at 3. What value could I use of B that would give me a continuous function? So pretty much, Thomas, here we got that hole. We want to know what value would fill in that hole. All right, so what I can do for this one is I can say the limit as x approaches 3. I can do from both sides at the same time here because this function is defined everywhere except for 3. So it's left and right. It's just that one hole in the middle where it's not defined. And I'm going to factor. So on top I just have x minus 3. On the bottom I would have x minus 3, x plus 1. The x minus 3's will cancel. And so if I plug 3 in, I'll have 1 over 3 plus 1. Which will give me 1/4. And so if I made b equal to 1/4, then that would put a point right there at 3 1/4. They'll fill in that hole in the graph. That's all you have to do for that one. Now let's look at the next one. It's a little different. So I want you to do the same thing, but it's a little bit different. Alright, so we want to find the value or values, there could be more than one, of b that will make f of x continuous at x equals 2. So I need the limit to exist for this to be continuous, correct? Which means I need the limit from the left to equal the limit from the right. So I'm going to do this. The limit as x approaches 2 from the right of f of x has to equal the limit as x approaches 2 from the left of f of x. So if I'm doing the limit as x approaches 2 from the right of f of x, I'm using that top function. And I'm plugging in 2 for what variable? X. Not for the b. The b is still going to be there. So I've got 8 over 2 plus b. And then for the other side, I would have 2 times 2 minus b. So this has created an equation that only has b's. So we can solve this. So we got 8 over 2 plus b equals 4 minus b. Everybody's with me there, right? We got 2 times 2 down. Okay? All right, I cannot solve this. I cannot solve for b's when they're in the denominator. So this 2 plus b's got to go. How do I get rid of it? How do I get it out of the denominator? Multiply by 2 plus b here, which is just going to cancel. And then make sure you put parentheses around 4 minus b. You're going to multiply 2 plus b here. And so over here you'll need to distribute. You'll get 8. You'll get plus 4b minus 2b minus b squared. Distribute, so 4 times 2, and then 4 times b, and then b times 2, and b times b. It's that FOIL, maybe you might have heard a teacher call it. We don't call it that as much anymore, but you've blocked it from your memory. But you do it as early as Math 1. Alright, so how do we solve a quadratic?
Quadratic formula.
That's one way, but it's not the easiest here. Anytime you have a quadratic, we'll move everything to one side. So I'm going to move everything over here to the left side so that that b squared will be positive. Actually, let me combine my like terms first. So you got b squared minus 2b, and then when you move this 8 here, it actually cancels on both sides. So b squared minus 2b equals 0. We factor out a b. And so b equals 0 and b equals 2. You're doing b minus 2 equals 0, and then you just add that 2 to each side. So you just set whatever you got right here, you're going to set each piece equal to 0. Yeah, we did it some 3 times. Okay, we do not have time. Yes, that's all you have to do. We do not have time to go through all this. Okay, no, we can. All right, let me look at the homework really quickly. If somebody wants to go ahead and pass out wipes while I'm looking at this real quick, that way I'll hold it. All right. Okay, for the last one, do not do A.
It's just that one.
Or
B or C.
yeah, you just do B. Only do B on that last one there. So when you upload that, you can just, you'll just click the picture here and you can just upload the picture from your device there. Or you can type it, but if you type it, you need to use lemon notation, which you can't really do. Just write it on a piece of paper, take a picture, and upload it. It's the best way.
That quiz
For that last
that's
one.
limited attempts, that's like an okay quiz now, right? Like there's no...
Yeah, it should be good now. There should not be any issues with it. As far as I know. If you find a mistake, let me know. It's worth bathroom pass now.